Hello, hope everybody's doing well. Got a pretty cool video for today. So every now and then I get a comment on this truck. A lot of people saying, what happened to that big truck? Did you give up on it? Did you put it on the back burner? Yes, I kind of did. So a little rundown. A long time ago, I built these axles. These are heavy. They're really strong, but they're really heavy. They're just made out of some 1/8" chromoly plate I had laying around the shop. I did a rush job well in between working on customer cars. And that was cool at first, but now with the CNCs, the axles don't match the rest of it. So I knew I wanted to change that. So I'll show you what I come up with. I wanted to wait and show you guys the housings I made, but a lot of people keep messaging me on Instagram saying, oh, what are you working on? It gives a little hint, little teaser. So check this out. Look at that right there. That's an awesome looking axle. And the cool thing about it, it's dual servo behind the axle steering. Check that out. It's an awesome upgrade. I spent a lot of time designing these, and check these out compared to the full-size monster truck axle. Check that out, very, very similar. So on a monster truck, the way the axle's put together is you got your main housing. This piece right in here is called a champagne because it's kind of shaped like a champagne glass. Not so much these ones, these are aftermarket, made by a very, very talented guy. Same thing with these knuckles. So you got the inner knuckle, outer knuckle, and then the hub and everything. So I wanted to make a housing for the RC car. It's just like this, kind of put together the same way. And I think I achieved that. So I'll put this on the bench. I'll take it apart real quick just to show you how everything works. So there's 6 screws holding the inner knuckles to the axle housing. So see, that has that little ridge right there, and it fits right in there. So the screws don't just support this like up and down, side to side. They just kind of mainly keep it clamped on. And then this is where a lot of the strength comes in too. So it's a little bit stronger than if I left that feature out. So that's pretty much what the monster truck housing looks like in the full size. You got the flange right there. So here, this is pretty cool. So on the old steel housings, there was just one servo. There was a rod going from here to the knuckle and knuckle to knuckle. It was bent all funky to clear the drive shaft and links. And then I made like a little kind of internal spring servo saver. It didn't work quite well. There were some issues with that, especially because there were no steering stops, so the wheel would turn so much, it would put a lot of strain and it would destroy servos. One servo would last maybe 3 or 4 runs, if that. So I came up with this setup. It's got the dual servos right here as servo savers. I found this company that makes these precision ground stainless springs. They're really nice. So there's adjustment right here. So the final version we use shorter screws. I just had these kicking around, but I ordered the right length screws, all stainless hardware. And you can crank that down, and if you don't want this to travel, like if you only want it to travel a little bit, you just tighten that up and the spring would get coil bind. But this is, I think this is perfect. This week, all the little joints and everything and the aluminum rods that I can machine on the lathe will be here. So I'll get those hopefully made by like end of the week. And then I can get this on the truck tested out. So now I'll pop this off and you can see what it looks like inside here. One thing I wanted to do too was make it so all these screws can be accessed without having to remove the servos. It works good with these Savic servos, but some servos are a lot bigger than this, so I don't know if all will be that way, but I could have just moved these screws over a little bit and that will clear a bigger servo. But the thing about that is, I'll show you when I get this cover off. Doing so, I would have had to add more material and would actually weaken the housing. It's funny how you would think adding more material would make it stronger, but what happens is if you make one part too strong, it forces all the pressure to one place. It could actually crack the housing. That's what's cool when you have a simulation software. You could check all that stuff out before you build it. So right there's the inside cover. And that right there is from a Losi DBX-LE 2.0. I decided to put that diff in here for now until I start making my own. I got a company that I've been talking with that makes gears. So I don't make gears. I could, but it's not what I'm an expert at. And those things have to be done right, like heat treated and everything. So for now, I made adapters to mount this. But then once I get those gears made, my own housing will go in there. So that's pretty cool. So I'll pop this out real quick. So there's screws in the bottom right here. And this part is the upper link mount. Notice how it's at the proper angle. And everything sits in a pocket like that, real snug. So just like with these inner knuckles, when it sits in the pocket like that, the screws hold it down, but the pocket keeps from moving side to side. So just add strength. So now that's unscrewed. Check this out. This is cool. Fits snug. So that's a DBX-LE 2.0 housing, but this also works with the version 1. So they made a ton of those. That's why I chose this. And I know from having those trucks, those things are insanely durable. And they made so many of them because you had the DBXL version 1, version 2, DBXLE version 1, version 2, and then also the MTXL. So that's a lot. If you go on eBay or Marketplace, there's tons of these things. So there's never going to be a shortage. It's kind of like on a full-size monster truck. I wanted to make it the experience similar to when you build a full-size monster truck axle. You get your housing, you got to find the center diff, which is usually a Rockwell F106 or 2145. It's pretty common now. So these are pretty cool. They're just 2 screws. They got the little notches. These are the lower link mounts. And then the shock mounts. And those are the same thing. Everything fits real snug in this pocket. Like that. So that's pretty cool. So what's neat is this housing, just the main housing without the brackets, without the inner knuckles, weighs 1.2 pounds. I'll show you what this starts off as. Starts off as this. Look at the size of that thing. That's 19 pounds. And then it turns into 1.2 pounds. So that's a lot of material removal. And every piece is precision made. So this will be cool. I'm really psyched to get this thing running. So I just want to give you guys a little teaser. A lot of you guys asked. So I don't know, I figured to share it with you. So let me know what you think. That's cool. I'm definitely pleased with how this came out. All it's machined out. It's really strong. If you take a look at all the features in here, so when you see it on camera or in a picture, you can see almost like little lines and swirl marks, but it just looks funny on the camera. But when you run your finger, it's smooth as glass. And I changed all these angles, not just for looks, but it's crazy. Like, just by changing this angle by a degree or two, significantly increases strength while allowing it to make for like a thinner wall thickness, so I can keep it lighter, but also make it stronger. So that's pretty cool. So earlier I was telling you how I wanted to move this screw over this way and this one over and down. But like I was saying, doing so, I'd have to add more material right here. And what that would do, that would put all the stress right here in between where it bolts in, and it would likely crack right here. So that's why I left it like that. So if a big servo is used, so you can get to all the screws with these Savic servos, but some of them might block that. So big deal if you have to take a servo out to get this cover off. Not a huge deal. Okay, so now I'll pop this back together real quick. Kind of like when you work on a car, those service manuals tell you installation is the opposite of removal. So these fit kind of snug. So it's easiest to just kind of hook that on there first. Put that in. There we go. I want everything to fit snug. You don't want this thing to just fall together. this just slides in here, nice and snug. Leave these a little bit loose. So now all 4 are in on the top, all 4 on the bottom. These are a little snug. I'm not going to go crazy because this is going to come back apart again. Put the lower link mount in. And this just goes over like that. It's important when you're engineering and building something that you make it so it's easy to work on, so everything goes together nice, all screw holes line up, things like that. Okay, and that's it. There's a complete housing. So like I said earlier, so this week, hopefully by Wednesday, the parts should be in so I can build the rest of the steering. Hopefully by the end of the week, I'll get this thing in the truck and running. Might be next week though, because I have a job with the machine shop. I also do what's called job shop work. That's where, like, if someone comes to me wanting something machined. So in this case, a local engine builder makes some crazy motors. He actually did a couple motors for me. Like, I'm talking like 5,000 horsepower, like top fuel motors and stuff. He needed some parts made, so I got to get that done this week. This was a test housing, so this was started out as a block of that, but this was just to test the different tool paths and so I get the right surface finishes, and also like for machining time, because just doing this outside, a couple hours worth of machining. So here's another one of these pieces. Anyway, just figured I'd share this with you guys, and I'll have another video as soon as the truck's up and running. So take care. Thanks for watching. Like, subscribe, bye, hit the bell.